Welcome to Snap's Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about experimentation technology. This topic is based on a tech blog titled How Walmart Leverages CUPED and Reduces the Experimentation Lifecycle, written by their data science team. You can find the blog link in this episode's description. Throughout this episode, we will dissect this topic from both business and data science angles. Now, let's dive in. On the business side, let's examine the problem to be solved.
What is Walmart and why do they need to run online experimentation?
Walmart is one of the world's largest retailers. It operates a vast network of stores and e-commerce platforms, serving millions of customers worldwide. To stay competitive and continuously improve, Walmart relies heavily on online experimentation. This approach helps them make data-driven decisions across their operations, which include activities like fine-tuning pricing strategies or improving the user experience on their website. Walmart runs experiments to test and evaluate which changes produce the best results. For example, they might experiment with new product page layouts to see if any changes lead to higher online sales. By running online experiments first, Walmart ensures that large-scale changes are backed by solid data, minimizing the risk of introducing ineffective changes and maximizing the likelihood of success.
Online experimentation sounds very important. Are there any challenges involved?
Absolutely. While experimentation is crucial for informed decision-making, one major challenge is the time and resources required to complete each test. For instance, if an experiment takes a month to finish, Walmart can only run 12 tests or evaluate 12 ideas in a year. But if they could conclude an experiment in just 1 week, they could test 52 ideas in the same time frame. A key obstacle to concluding experiment results faster is statistical variance, which refers to the fluctuation in test results that can obscure the true impact of a change. For example, if Walmart tests running a Pokemon-themed website in October in preparation for Halloween, there could be situations that the first batch of visitors are mostly elementary kids, leading to a higher conversion rate at that moment. But at a different set of customers visiting the sites, it is very likely their behaviors are different, causing sales performance to fluctuate. These fluctuations contribute to the sales number results variance. If the experimentation only runs a very short time window, like 2 days, the fluctuation could be high, and this makes it difficult to tell if an increase in sales is due to the new theme or just by accident. So reducing the variance is essential for conducting faster and more accurate experiments.
Great. Now I understand the business problems and challenges. Can you explain more about how the team plans to solve it?
Of course, to reduce the variance in online controlled experimentation, we first need to understand what causes it. In these experiments, we usually take a small sample of customers to estimate how the broader population will respond to a change. However, because the sample includes highly diverse users, such as kids, adults, and people from different regions with varying interests, it often leads to significant variations. Unlike fields like medicine, where researchers can carefully select similar test subjects to reduce variability, that is not feasible in the online world. For companies like Walmart, many external factors come into play, such as seasonal sales, holiday shopping specs, or even a celebrity promoting a product on their social media. These influences make it challenging to determine whether the difference between control and treatment groups are genuine signals or just noise. Additionally, online controlled experiments often measure small metric changes, or lifts, because many product changes result in incremental improvements to optimize the user experience, rather than introducing a major disruption. When small lifts combined with high variance, power analysis shows that experiments may require millions of samples to draw reliable conclusions. Now that we understood the root cause of why variance happens, let's explore one solution: CUPED. CUPED is CUPED, stands for Controlled Experiment Using Pre-Experiment Data. It reduces variance by using data collected before the experiment starts. The idea is simple. By leveraging pre-experiment covariates, or those data points that are already known before the test, you can adjust for variability that might otherwise distort the results. Essentially, CUPED helps remove the noise by accounting for factors unrelated to the treatment. This allows the experiment to focus on the real impact of those changes. Imagine a situation where Walmart is testing a new homepage layout to see if it improves the average basket size. Normally, without CUPED, the experiment would compare the average basket size between two groups, one seeing the new layout, which is a treatment group, and the other seeing the existing layout, which is a control group. However, because different users have different shopping patterns and with different external factors, it can lead to significant variation. Here is where CUPED comes in. Walmart's team could use pre-experiment data, such as each user's historical average basket size over the last month, as a covariate. By knowing that a user typically spends around $50, CUPED adjusts the results to account for this baseline behavior. If that same user now spends $70, CUPED attributes only the portion of the increase that can't be explained by their usual spending patterns to the new homepage layout. By filtering out these predictable variations, CUPED helps isolate the true effect of the new layout on customer spending. This is essentially how CUPED works. At Walmart, their data science team developed a customized version of CUPED, guided by three key principles. First, the solution had to be straightforward and avoid black box methods. In their experimentation setup platform, customer data is processed from multiple sources in a daily batches, ensuring transparency in how the data flows and how decisions are made. Second, the approach needed to be tailored to Walmart's specific context. Many of their customers return to the platform regularly, which means that the team had access to a wealth of historical data for each user. After the team tested various options, they found that using the past 4 weeks of customer data as the covariate provides the best results. Lastly, the solution had to support their business goal. Since product teams often rely on group means to make decisions about launching new features, the team implemented a demeaned version of CUPED. This allowed them to preserve the original group means, ensuring the results were easy to interpret and aligned with how the business make decisions. There are more granular details, including mathematical formulas in the blog post, which I highly recommend for those interested to take a deep dive. From a result perspective, after the team deployed this approach, they observed a significant variance reduction across different interfaces, ranging from 5% to 20%. This reduction helps the team to get more conclusive experimental readings earlier. Imagine if all product teams could conclude their online experiments 10% faster. That would mean over 100 million of Walmart customers could experience the new feature 10% sooner, leading to a better customer experience overall. Now that we've discussed both the business problem and the technical solution, let's wrap things up. In this episode, we discussed why Walmart relies on online experiments to drive data-driven decisions, and how reducing variance is a crucial challenge to make these experiments more efficient. We introduced the CUPED methodology, explaining how the companies leverages it to speed up their experimentation process, enabling a faster and more reliable insights for continuous improvement. If you like the content of this episode, please subscribe to the channel, give me a 5-star review, and leave a comment. Your feedback is very appreciated, and I'll see you next week.